Hey everybody, my name is Eric Navala. I'm a software developer with probably about 17 years of experience, and I've been working with Unreal Engine for the last 3 years. I've been working on my own project, so I thought I'd give you guys a pretty detailed class on how to use C++ with Unreal. So we'll go through how to create a project with C++, how to add a class in Visual Studio, how to access that class inside of Unreal Engine using inheritance, and then we'll figure out how we can reference stuff from our C++ class and blueprints. Then we'll dive into debugging our code in Unreal Engine and Visual Studio, and then we'll add some really simple functionality just to show the interplay between C++ and Visual Studio and Unreal Engine. I'm going to be assuming that you have some experience using Unreal Engine or blueprints, preferably at least 6 months. This is not going to be a beginner class on how to do programming or how to use Unreal Engine. With that being said, we'll get started. The first thing we want to do is start a new project. I downloaded the Unreal Engine source code from GitHub and I installed it and compiled it and ran it, and this is what I ended up with. I'm using Unreal Engine 4.18.3. You can use any version you want. I don't think there's going to be much of a difference. There's a couple different ways that you can start a new project. The first thing you can do is open up the UE4 solution file, double click that and open up Visual Studio, and then you can compile it. If you've already compiled it, then you should already have a binary, and you can launch that binary instead. So it takes a little while for UE4 to launch through Visual Studio, so we're just going to go the fast way and launch Unreal Engine through the binary. You can find that inside of the engine folder. Just double click this, then you go into the binaries folder, then you go into Win64, and then you see a whole bunch of binary files like DLLs and executables. And what you're looking for is UE4 editor.exe. You can double click this guy, or you can drag it down into your start menu so that you can have easy access to it. I'm just going to double click this. Alternatively, you could also use the Epic launcher to launch Unreal Engine, but the Epic launcher only shows engines which you have downloaded and installed through their binary installer. If you have a source build, then it will not show up. This is a source build, so I'm just going to launch this guy right here. Now it's going to take a couple minutes, or not really minutes, but a couple seconds for this to load. And then it's going to come up with a dialog asking if we're creating a new project or selecting an existing one. And we're going to be creating a new project. Okay, here's the project selector. So we're going to hit the new project tab. We're going to hit the C++ tab, and we're going to have a basic code project, which is pretty empty. It's going to be a desktop console project with maximum quality and no starter concept or content. We're just going to call this demo project, and then we're going to create this project. If you already have an existing project, this is relatively straightforward to add C++ code to that as well, but we're just going to start a new project so that everybody starts with the same page. Okay, so it's going to go through and create that project, and then it's going to open that up. So that project will be stored inside of your Unreal Projects folder. This is going to be in your Documents / Unreal Projects, and this one is going to be called Demo Project. So we open that up, and it is also, I believe, opening up Visual Studio 2015. So I have two versions of Visual Studio installed on my computer. I have Visual Studio Community Edition 2015 and also 2017. The community editions of Visual Studio are free online, so you can download that and install it anywhere, and you don't ever have to pay anything. I think we should all give Microsoft a great big thank you for that. The exact steps that you need to take to install Visual Studio so that it's compatible with Unreal Engine are probably beyond the scope of this video, but if you wanted to, you could go on to the unrealengine.com website and read the step-by-step instructions on how to set that up. So I guess while we're waiting for Visual Studio to load, we can go through the anatomy of an Unreal Engine project with Visual Studio source code. So with a brand new project, you're going to have this VS file. This is normally a hidden file, and this is mostly for Visual Studio. If you wanted to, you could delete this. It's always generated anytime you launch Visual Studios through a solution project. Then you also have a configuration file. This is going to have a whole bunch of INI files which have project-specific settings. Then you're also going to have a content folder. This will have any content that you include in your game. So this will be like sound assets, art assets, models, meshes, pretty much anything that is required for creating art or blueprints or anything in your game. You'll also have this intermediate folder. You should always assume that anything in here can be deleted at any time. Most of the stuff that you'll see in here are going to be project files, and these are all the project files that are being referenced by your solution. And if you open up Visual Studio as we have it open here, you can see each of these projects listed on the left hand side through our Solution Explorer. And then you also have the source code directory. This is where all of your code will go. So if you open this up, you'll see a combination of CS files. These are C# files. And you'll also see .h files and .cpp files. These are header files and the actual C++ files. Now, since we also have Visual Studio open, you can see the source folder right here as well. This corresponds to this source folder right here. And you can see the CS files right here, also listed right here. And if you open up demo project, you can see that these files correspond appropriately here. Okay. Then if we go back to our project, you also have an SLN file. This is your Visual Studio solution. And you also have a U project file. This is a very important file. Never delete this. You also have your demo project.vc.db. This is the Visual C database for your Intellisense data. If you look down here, you can see this little blue ribbon that says parsing files in solution, 7,000 out of 19,000 files. Basically what that's doing is it's going through this whole entire Unreal Engine project and reading every single source code file and building a database so that when you're typing code in Visual Studio, Intellisense will help you use the correct keywords and type correct code before you actually try to compile it. You can delete this. It doesn't matter if you do. It will always be generated every time you run Visual Studio for the first time. So if we actually hit F5, you can actually see this file size increasing as this database is being built. And I think that's about it for the folder structure here. I think before we actually run this, I'm going to delete a whole bunch of that unnecessary stuff and then show you how to rebuild it. This is going to be super important if you want to share your project with other people through either zip files or putting it up onto version control. So this folder is not necessarily needed, so we're just going to delete that. We do not want to delete the config folder. We do not want to delete the content folder. The intermediate folder is temporary files pretty much, so we delete that. Hit yes. The source folder contains all of our super valuable source code, so we don't want to delete that either. The SLN file, we don't need that, so we can delete it. And the same thing with the vc.db. This is the Intellisense database, so we'll delete that. So these are the files that you need. So if you wanted to rebuild all that stuff, all you do is you right click on this uproject file, and you can either generate Visual Studio project files or switch Unreal Engine version. So if you switch Unreal Engine version, this lets you select which version of Unreal Engine you want to use for building this project. I currently have it pointed at the source build. Alternatively, instead of using this drop down menu, you can also select this button right here, which lets you manually point to a build of Unreal Engine. If I hit OK, it's going to start generating project files, and you can show the log and see the progress as it goes. Now you'll notice that once it completed, we have this VS file again, we have an intermediate folder, and we have our demo project solution. So to launch Visual Studio, all we do is double click the solution file here, and it will go through and start opening the project and all the dependencies that we have listed in the intermediate folder. And it will also start building that vc.db Intellisense file again. So if we start refreshing this, one sec, it needs to finish. Now it's going to go through and start scanning the project, and you can see that this is increasing as this little progress bar increases. But we don't have to wait for that to complete. We can start launching this anytime. So the one thing that's really important to note is you want to make sure that this demo project is the startup project. The very first time you run this, it may actually have UE4 as a startup project, and this will actually just run that launcher that we were looking at earlier instead of launching our game. So if this is not set as a startup project, you can just right click on that and say set as startup project, and you don't need to worry about any of these other programs really. Okay. Before we actually run this, there's a couple other things that are important to go over. The most important stuff is the stuff up here in this ribbon. So this is our solution configuration. There's a whole bunch of different objects or options to choose from. You can select the configuration manager from here, or alternatively you can go to build configuration manager and set the active configuration for your Visual Studio project. The one that you want is going to be debug game editor. If you have it set to development, that means that a whole bunch of the source code that you build will be optimized away by the compiler, and you will have a very difficult time of debugging it. Some of the variables may be optimized away, which means you can't actually examine them during your debugging session, or your program counter will bounce around all over the place because I guess with the binary file, I'm not really sure how to explain this, but the flow of the logic will bounce around and only execute when it's needed rather than in a sequential order. So that makes it really difficult to debug runtime code or development code. Anyway, you'll just want to make sure that debug game editor is selected. If you're going to be doing a shipping or production build, you'll want to change your solution configuration to something else so that the code is more optimized for shipping. And we're going to be using the Win64 build instead of the Win32, so that's already set, and we don't need to worry about any of this other stuff. Okay. And I don't think there's anything else. So we'll just right click on this, and then we're going to be looking for debug, start new instance, and once we run that, our output log will start doing a build. And this should be relatively quick because there's not much to build. So the thing that you're always going to be most interested in looking at when compiling projects in Visual Studio is the output log. This is going to be showing what is happening behind the scenes whenever your programs are running. This will show all your log files and stuff in real time. Visual Studio also has this error list. I generally ignore this, especially for Unreal projects. The best source of your real errors are going to be this output log. You'll also notice that the output log has these little numbers right here listed by each of the tasks, and this is kind of like the phase of the build. So it's got like phase 1, phase 2, phase 3, and I believe it may even go up to like phase 4 or 5 or so. But basically the way a build works in any kind of engine or compiler is that first it goes through and looks at all your source code, and it parses that code and turns that into symbols, and those symbols are then turned into OBJ files. Those OBJs are like objects, and all of those OBJs correspond to each C++ file or class that you have. Then in the second phase of the compiling process, there's this thing called a linker, and what that does is it goes through and matches all the OBJs with each other based off of like different references. So if you write a header file which has a whole bunch of class definitions and function definitions, the linker will create an OBJ for the header file and then link it with a separate C++ file that actually has the implementation of those definitions. Now if you have like a function that's defined in a header file, but your C++ file does not actually implement that function, then you'll get what's called a linker error. What that means is the linker will be looking for the definition, but it can't find it, so you're going to have some problems. Basically all that most of the time means is that either your function definition signatures don't match, or you completely forgot to implement that function. So those are generally pretty easy problems to fix. In the worst case scenario, you may be getting linker errors, and if you know you have the functions defined and the signatures match, you may have to delete the intermediate folder that we talked about, this guy right here, and then completely rebuild that, and that should fix some of those linker errors that you have. And if you still have linker errors, then you've got some real trouble. Anyway, we're just waiting for this to generate all our code. I think it's worth noting that one of the key differences between running traditional C++ projects and an Unreal project is that Unreal uses this reflection system, which kind of generates this intermediate C++ code. Basically the way that it works is there's another step in the compilation process. So Unreal Engine has this program called the Unreal Build Tool. So if you look into the program section, there's this Unreal Header tool, and I'm not sure where the build tool is. Oh, there it is, right there, Unreal Build Tool. So it's kind of like a two-step phase. First, the Unreal Build Tool will go through all of your C++ code and look at the Unreal specific syntax, and it will use that syntax to generate the actual C++ files that get compiled. So you can think of your Unreal C++ code as something that's kind of like this intermediate between the actual C++ code. The C++ generated code you should never modify, because that can be wiped at any time. and it's built automatically. So the only code that you should ever worry about is the code that you write. Anyway, after the reflection system has generated the generated code, then the C++ compiler goes through and builds the binary OBJ files, and then the linker will go through and link it. And after all the OBJ files have been linked together, you get the executable file, which is then run. So I believe this takes a little while for the first time, and normally it doesn't take this long. So we might be waiting here for a few minutes. I guess while we're waiting here we can... Oh, no. Never mind. So here's the linker stuff right here. It says link blah 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 DLL link dot lib or library, and that means that we finished the compilation phase and moved into the linking phase, and now it's converting all those files into a executable file. And now we just saw this guy pop up. That means we're actually loading the executable, and the executable is now loading all the DLLs that it depends on. So this is kind of like the loading screen, and we're just gonna wait. Now once it starts loading, Visual Studio will kind of like change its interface state, and if you want to see what's happening, oh, what's this? You are debugging a release build of .NET Utilities DLL using just my code with release builds. I've never seen this before. We're just going to hit continue debugging. Maybe that's not important. Oh man. Fascinating. Weird. We're just going to start this over again and see what happens. Okay, you'll notice that took a lot less time, and the reason is because all those files were generated, so the amount of stuff that needs to be compiled is much less. But anyway, while this is loading, you see like this initializing ... 45%, and there's a whole bunch of stuff that's happening in the background. You can just open up this output tab, and you'll be able to see exactly what's happening underneath the hood, right? So if you're ever wondering, oh, why is it at 45%? Why is it stuck and what's it processing? Then you can see the output log in real time as it's doing the load. Some people will complain that, oh man, this is taking like an hour for it to chug through 45%, and I think my loader has actually frozen. But if you look at the output log, you'll see that it's clearly doing a whole bunch of stuff in the background. If it's never moving, then it's more likely that it froze. Okay. So now we have our empty project with pretty much nothing in it. Our level is this really simple demo scene that pretty much just has a skylight and a couple different elements in the scene. And there's not much to it. I'm just gonna wait for this discovery asset data to complete. I'm going to dismiss this plugins info, and we're pretty much ready to start. So whether you're starting a new project or working on an existing project, the way to add a C++ file is pretty straightforward. All you do is you go to the file menu, and then you go new C++ class, and then it's going to ask you which class you want to parent from. This is kind of like an inheritance kind of thing. So by default, I always inherit from an actor, but you can choose to inherit from any of these other ones. But this is just going to be kind of like this placeholder class that we're just going to delete anyway. So it's asking what you want to name the actor. So I'm just going to call it delete me. And then it's also asking you whether you want to put it into a public or a private folder. So I'm just going to put it into the public folder, and then I'm going to hit create class. Then it's going to add code to the project. And then it's going to try to use the built-in compiler to compile that code so that you don't have to actually shut down Unreal Engine. Well, I guess technically this is called the Unreal Editor rather than the engine. But the editor is trying to compile the code so that you don't have to shut down the editor. We're going to shut it down anyway. And then we'll go over the new source file. And after this is done, I'm going to show you how to add in source code manually through Visual Studio. And I think that's much more valuable. Come on. I almost never add classes through the editor because I don't want to wait for it to do this hot compile. I always do it manually through Visual Studio because it's so much faster. I strongly dislike waiting. Anyway, while that's running, just to save time, you'll notice that once we launched Unreal Engine, we've got a whole bunch of other folders. Now we also have this derived data cache folder and a saved folder. And we also still have this intermediate folder. The folder that we're interested in is this source folder. You open that up, you open up demo project. Now, you'll notice that we also have a public and a private folder now. These didn't exist previously. And I think if we open up Visual Studio, I guess this is a good time to go over this part right here. So Visual Studio says, hey, there's a new folder and a bunch of new files that I don't know about in my solution, and the solution has changed. Would you like to reload the solution? So if we hit reload all, well, it's going to ask us if we want to stop debugging. I'm going to hit no. So we didn't actually reload the solution, but you'll notice that there is no public folder and no private folder, and the source code files that we created do not exist here, right? And even though this is still loading, which is taking forever here, if we look into our actual Explorer window, you'll see the public and the private folder. And you'll see deleteme.h in the public file or public folder, and then private will have deleteme.cpp. Wow. I really don't feel like waiting for this, so what we're going to do is we're going to hit this stop button right here, and that's going to stop the whole entire Unreal Engine project. So the question is, how do we get this to match up with our Explorer window right here, right? You'll remember that Visual Studio wanted to reload the solution. So one thing we can do is hit close solution and open up our Explorer, and go back here and then drag the solution file in here. Come on. And that will reopen the solution. And now you'll see that we have a public filter and a private filter, and those two both contain our header file and our CPP file. Okay. Now every time Unreal Engine creates CPP files and header files through the editor, it will give you a whole bunch of boilerplate functions that it thinks you may want or need, but I tend to disagree about what it wants or thinks we need. So I usually create my source code manually through Solution Explorer instead of the Unreal Engine. So what we're going to do is we're going to delete these from the solution. So here's another really important thing to note. I can delete these files from the solution, but that does not actually mean those files are going to be deleted from the source code, right? So I hit delete, that's gone. I hit delete on that, that's gone as well. But that does not actually mean that those files are totally destroyed, right? And this point is going to be very important to note, because when you build your project in Visual Studio, if you still have files that you're not using, the build tool will go through and include those files. It doesn't scan your solution to figure out what files it needs to build. It scans your Explorer, and even if I hit build, it's going to still include these files in the build. So if there's any syntax errors, or if you have name conflicts, then you're going to run into trouble here. So I'm going to delete these from Solution or Windows Explorer. And there we go. Now if I build, we should be okay. I'm not going to waste your time by building this and waiting for that again. So how do you add a source code file manually? You just right click on this, hit add new item. The public folder will always contain your header files, so we're going to select header as a file type, and we're going to name that, let's call it pickup, in honor of the pickup tutorial that Unreal had. And you'll notice that this location is currently pointing at intermediate/project files. That is wrong. Remember, anything that's inside of the intermediate folder can be deleted at any time. So if you store source code in here and you delete the intermediate folder, you're actually deleting source code, and a lot of valuable work can be lost. So it's super important that you change this. You hit browse, you go to your demo project, and then you go to the source file or source folder, demo project, and then public. And you hit select folder. And then we hit add, and you'll see pickup.h got included. Likewise, you do the same thing with private. This private folder will always include your CPP files. You hit new item. We're going to be adding a CPP file, and we'll call this pickup. Actually, I'm going to call this pickup A. And then we're also going to create another one called pickup B. I want to show you guys how the linker actually works. It's pretty cool. This is a cool way that you can use the linker to organize your CPP files. Pickupa.cpp. Then, oops, that is not the button I wanted. Add new item. Oh, I made a mistake. I forgot to change this folder. So remember, you might be selecting the private folder as the place you want to store the file, or actually the filter that you want to store it in, but this does not match your Windows Explorer file structure. So you'll notice that it has public down here, even though I right-clicked on private. You still have to go to browse, go up one directory, select the private folder, and now we should be correct. But this is a good way to illustrate how you can fix a mess up. Okay? So you saw that error I made, right? Now, if you open up the public folder, you'll see pickupa.cpp in there. Instead, I want that to be in the private folder. So I'm just going to Control X that to cut it. Go into the private, Control V. Now it's pasted there. If you look in the private, it should be gone. Yep. Now we want, well, I guess that now matches the Solution Explorer. What happens if I open this? Okay, that's correct. Good. All right. So we have a header file and we have 2 CPP files. So a header file pretty much contains the definition for our class. Think of it as a dictionary, and the header file just contains all the different words of the dictionary. And then after you read past the word in the dictionary, it's going to have a whole bunch of different meanings to that. The meanings for those words, or the definitions, are actually going to be kind of like implementations, and those are going to be stored in the CPP file. So for every single class, the first thing we start off with is the uClass. Oops. This is an Unreal Engine macro, and then we do class, and then we'll call it a pickup. And then we want to inherit from the actor class, so just do public a actor, and we create our curly brackets, and then the next piece is going to be the macro for the insides of the class, and that's just going to be generated body. It's important that you do not put semicolons after this. If you do, you're going to have errors. By default, I believe the generated body is going to be in the private namespace, so you'll want to create a public namespace, or actually these are not namespaces, but kind of like just access levels. You may also have a protected access level, and then you may also have a private one. So the first thing that we're going to be interested in is going to be the class constructor, and the best way to create that is you just use the name of the class, a public, and then it's going to be const f object initializer, and that's going to be passed by reference, and we're just going to call it object initializer. And then we'll also create a function called do something, and this will be a void return type, and we're not going to pass it any parameters for now. Now you'll notice that we have this little green squiggly line, and this is Intellisense helping us by telling us that the definition for this function does not exist yet. So if we compiled, we would have a linker error. We'll create another class called do something else. Okay. So now we have to go through and give these guys definitions in our CPP files. So the easiest way to avoid human error is to just copy your function, go into your CPP file, paste it, and then I'm going to use wait, why is it public? This is supposed to be a pickup. I'm already having human errors here. And then anytime you have a constructor, you want to call the parent class constructor before you do anything else. So in this case, we're going to be doing super actually, I believe it's going to be super and then pass in object initializer. Boy, my spelling is terrible. Maybe it's because I feel on the spot. IZER, initializer. I'll go repair this one here. Okay, perfect. And then we will implement do something in this guy right here. Copy that, paste that here. Put our curly brackets in, put in the correct namespace, a pickup. Do something, and then we'll just have a to-do kind of comment. And then we're going to take the do something else and we're going to put that into the other CPP file. Okay. And then we also want these to be values that we can access and call through the blueprints. So we're going to start taking advantage of the Unreal Engine reflection system. The way we do that is we do u function, and then we're going to call it, or put in a keyword for blueprint callable, and we'll give it a category pickup. And then we'll copy and paste that. And we can also add a comment above this. So the cool thing is, the Unreal Engine will take this comment, whatever we write up here, and that will turn into a tooltip that people using the Unreal Editor can read. So this is a cool way for you to help your less programmer type of friends or designers understand what your function is actually doing. Just for the sake of demonstration, we're just having a really bad comment up here. And we'll modify this later on. We have a pickup, and when somebody runs into it, let's say that we want to increase their score by some number, and the amount that we increase their score by will be stored inside of an integer variable. So we'll create an int32 score, and we'll default that to be a value of 100. You'll note that we use int32 instead of just the integer that comes with C++. And this int32 is actually a type that's defined by Unreal. You want to use the Unreal types because if you're doing cross-platform development, Unreal has a cool way of figuring out the correct variable type to use depending on the platform that you're deploying to. So if you're deploying to PC, this int32 would be just the keyword int for C++. If you're deploying to PlayStation 4, it would probably be something else. But if you wanted to make this value exposed to blueprints, you use a u property with a y. Then we say blueprint read write. We can edit this anywhere, and this will be in the category of pickup. That's a little bit more of a helpful comment. Now you'll notice that I put this inside of the protected category instead of the private category, and also not in the public category. This kind of changes how this value is accessed. So only classes which inherit from a pickup can access and modify this value. It's kind of treated as a private value except by any objects that inherit from it, right? And let's see, are we ready to go? I think so. I wonder if we should implement the tick. No, we'll do that for the next run here. Alright, all you do, hit play. It's gonna run. The build is gonna happen. Let's cross our fingers and hope for no syntax. Oh, I am gonna get major errors. Let's pause this or cancel this. I'm gonna hit Control Pause to break the build, cancel it. The super important thing that I forgot to do is actually include header files up here. So I just need to do #include pickup.h, and same thing up here. And then I think this one is going to need #include pickup.generated.h. If you don't include this, then you're going to have some problems. Basically, we're making a way for our reflection code to be generated correctly. The actual C++ code will be stored in here. So we'll hit OK or hit run. Now the very first time that you run this file doesn't actually exist yet, so you're going to have these red squiggly lines underneath include. But every subsequent time, that header file will be found. You'll also notice that there's red squiggly lines under a whole bunch of stuff, and I think the conclusion is that Intellisense is not actually all that intelligent when it comes to processing Unreal Engine's macro code. These are all macros, by the way. So a macro is like copy and pasting a large chunk of code and hiding it behind something that looks like this. Alright, now we're just going to wait for this to finish. It might take a little bit of time. Okay, that finished. The linker happened very quickly. If you didn't catch that, you can always look at the different outputs. So if you look at the build order, interesting, it didn't show much for the linker error info. Anyway, what happened with the linker? Let's go back to the Visual Studio really quick. It created two OBJ files. Each of them correspond to these different pickup.cpp files. And then the linker was able to match up the two different function definitions that we created here with each of those different OBJ files. Okay. So now we have a whole bunch of C++ code that kind of defines this pickup class. If you wanted to add it into your project, what you could do is, hold on, I'm going to change my view. I'm going to hide the engine content. So you've got this C++ classes folder here, and you've got this demo project folder here, and also a public folder here. And we have a pickup. So if you wanted to, you could bring this pickup over into your scene and see that object inside of your world outliner. And you can see this score is equal to 100, and we can change that value. But that may not be as useful as we want. Maybe we wanted to create a blueprint and then call some of those functions that we created, like do something and do something else. So we'll have this content folder selected just for the sake of organization. I'm going to create a new folder called blueprints. And then in here, I'm going to create a new blueprint class. And it's going to ask what class do you want to inherit from. And I don't want to inherit from any of these. I want to actually inherit from our C++ class that we just created. So I'm going to select this all classes down here. You'll notice that this actor is in light blue text and all the rest of these are in white. That means that there's a custom object in here that doesn't exist in the vanilla version of Unreal Editor. If you expand this, you'll see a whole bunch of stuff, and the one that we're interested in is going to be pickup. So you can either find it manually or you can just type it in. So I'm just going to type in pickup, select that, hit select. I'm going to call this BP_pickup. It's my own personal convention to have a BP_ prefix for every blueprint class, just so that I can know what the difference is between blueprint classes and C++ classes. If you open this up, now we are looking at the blueprint editor, and you can see our scene hierarchy here only has a scene root, and if you select this class right here, or this, I'm not really sure what to call this. I guess this is the class view, or class defaults view. You can also see the score right here, which you can modify. If you go to the event graph, you can also see the basic events that you can modify if you wanted to. This should be pretty familiar to you if you've used blueprints quite a bit. So let's call some of our functions that we created in C++. So I'm just going to right click here and do something. So we're going to call that during begin play, so that only happens once. And then every tick we're going to do something else. Okay. There we go. Now we don't actually have any code in these classes, so this is not actually going to do something, even though it says do something. Just for the sake of visibility, I'm going to add a sphere component, then hit compile, and then we can actually see our pickup. Okay. I'm going to create a levels folder. And then if I hit save, it's going to ask us to save this level. And call that start level, hit save. Go into the project settings, maps and modes. We're going to set that start level as our start. And game start. We're going to hit save, save. If we hit play a new window, you should, let's see, where is it? Oh, I didn't actually add it into the scene. So we have to just go into the blueprints and then add in our pickup. And there we go. There's our pickup. So the really important thing to note is that our blueprint can read the values of our C++ class, but it does not go the other way around. Our C++ class cannot or does not know about stuff that we do inside of the blueprint. So you have to be very careful about how you organize your different sections of code and where things are defined. The only way that you could pass information from your blueprint into your C++ code is by creating a function in C++, which has a whole bunch of function parameters, and then you would pass whatever you want through a function parameter, and then C++ can figure out how it wants to handle that. That might be a lesson that we talk about a little later, probably not in this video. Alright, let's actually do something cool. Our pickup is pretty straightforward. All we want is for somebody to run into it, and once they run into it, we want to increase their score by some number. So I guess we can implement some of that simple functionality in our blueprint. So the first thing that we want to do is make this sphere so that people do not collide with it. Instead, we just want people to overlap it, and if they overlap it, then we want to capture that event, which is already here, and then we want to figure out if it's a player, and if it is, then we want to increase their score. So that's a little bit more involved than it sounds. So the first thing that we have to do is actually create a player. So I'm going to create just a pawn. And here we're going to create a variable called total score, and this is going to be an integer. Oops, not a float, but an integer. If we compile that, you'll see that the total score defaults to 0, and that's pretty much it. The other thing that we have to do is also create I believe a game mode. Yes. So let's see, game mode, where are you? I may have to search for it. So it's very important that you inherit from game mode, not game mode base. If you screw up and inherit from game mode base, you're going to run into a whole bunch of problems, and they may not be obvious. I'm just going to call that demo game mode. It's worth pointing out that your C++ project also has a demo project game mode base class, and you don't want to inherit from those, but they do exist. So we're going to select that as our game mode. Let's see, BP demo game mode. There we go. Then we want to open this guy up, and the default player pawn is going to be the BP underscore player pawn. Okay. And then just to test, we have our player pawn, but it does not do anything right now. I'm pushing WASD and it's not moving, and I'm also trying to move my mouse and that's not moving either, so we have to go through and add in that functionality. It's relatively quick, so we just go to project settings. We're going to be modifying the inputs. We're going to have actions and axis mappings, so I think we only want axis mappings. We'll call this move forward, and then we'll create another one, move right, and then turn left and look up. So this is going to be the W key, and also we're going to have the S key. Let's find that S key. There you go. And for S, all we're going to do is invert the scale by -1. And for this, move right is going to be D. And then we'll also have an A to move left. And we're going to invert that scale as well. For turning left, this is all going to be mouse X. Oops. And then looking up is going to be mouse Y. Oops, I said mouse Y. There we go. And then we go into the player pawn, event graph, and we're going to be calling those events. We're actually responding to those events. move forward. I think it was move right. Yes. We want to get the player pawn. I guess it's already going to be the self, but whatever. Then I believe it's going to be add movement input. Yeah. I only know this because I've got quite a bit of experience doing this over and over again. If you're new to this, then you'll probably have to look it up a couple times until you get the hang of it. And then we're going to be getting the forward rotation, get the forward vector, and that's going to be based off of the pawn rotation. So get world get actor rotation. So we feed that in, and that will give us our forward vector. And then the axis is going to be either a value that ranges between -1 and 1. So we're just going to be multiplying that by the forward vector. Vector times float. There we go. Like so. Oh. Interesting. I wonder if I could pass in this axis value into the scale value. No, I don't want to do that. Maybe this could be like something like a mouse sensitivity or something like that. Get right vector. And then we're going to multiply this by the axis as well. Vector times float. That's the axis value. Pull that in there. It should be good. Compile this. And we're going to test it really quick. And it does not seem to work. Why? Alright. I'm going to hit or put some breakpoints here and see if these are even being called. Yes, they are. What if I break all these links? Compile, try this again. Nope, still does not work. What could be happening? We know that the game mode is calling the player pawn. The player pawn is getting these events. So we're just going to do some print strings. So we're not going to print out the log. Duration is going to be 0, so we're going to be seeing the real-time value of that. If we hit play, oh, let's try adding a camera component. We may actually be moving the actor, but the view may not be changing. Nope, I was wrong about that. Alright, so the cool thing is, if I hit forward or back, we can actually see our value changing, so that means our inputs are being mapped in correctly. But our actual pawn is not moving, so maybe there's a little bit more to this. Let's add in a sphere component for the pawn. We're going to take this camera and move it on top of the sphere, like so. And we're also interested in seeing our side movement. Okay. Maybe adding movement input is not the right way to do this. Alright, we're just going to do this manually instead of using the movement input. We're going to set the actor location. And we're just going to take this value and add it to whatever the actor location is. Oh, that's not what I wanted. Get actor location plus this vector value. Oh, come on. Let's delete that. Okay, good. That works. We'll do the same thing for the sideways movement. Oh, that's not what I wanted. I believe the add movement input is better for characters that actually have a movement component. Since this is a pawn, we don't actually have a movement component by default, so if we wanted to make our pawn move, then we would have to add in the movement component. Okay, there we go. Now we can move around. Now our pawn character has the capability of actually running into that pickup. The last thing we want to do is give ourselves the mouse look. So we want to capture this look up event and then the turn event. Turn left event. And then we want to change our actor rotation. And then we want to combine this with a rotator and set our actor rotation. And I'm going to split this struct, and if you're looking up and down, you're going to be changing your pitch value. So we want to get the actor rotation, and we want to add, oh, that's not the right way to do that. We want to add the axis value to the pitch, and then we're just going to copy these other values across. Let's see if that works. Yes, it does. Perfect. Now we just have to do the turn code, which is going to be roughly the same. But instead of doing pitch, we're going to be doing yaw. And we're just going to copy the existing pitch value, like so. And that should be good. There we go. Now we have WASD movement and mouse look movement code. And it's all being done in blueprints. You could also do this in C++ if you wanted to. Alright. What's next? We want to see if we're actually colliding with the pickup. So we want to capture the overlap event. So when this happens, we want to just print something to see if it's even being triggered. And maybe we'll also want to know who triggered it. compile that, let's run it. Alright, and should be looking for an overlap event, which got triggered, and it did. That's good. Perfect. Okay. The next thing we want to do is, oh, we already have the score. Alright, perfect. Even easier. So whatever actor gets, or whatever overlapping actor we have, we want to try to cast this into our BP player pawn, and then we're going to get its score. And we're going to pull this score from our pickup. We want to get the existing score from the actor and add the score from the pickup and set that to the new score. Okay, should be pretty straightforward. Compile that, and then after the score has been set, we want to destroy the pickup so that you don't pick it up again. And if you wanted to be really fancy, you could have sound effects at play as well. Let's just test that it works. There we go. And then every tick we will want to display the player's score. And that's going to be the total score. Oh, I'm going to pull this out, wire that up, like so. We're just going to print that to the screen, and no delay, and it's going to be in red, so that's visible. We also don't care about this debug code anymore. Now the score is 0. We run into the pickup, now it's 100. Okay. So our pickup is pretty boring right now. It doesn't really do anything. So let's say that we wanted to make it move up and down on kind of a sine wave, and we don't want to do that implementation in blueprints. We want to do that in C++. So we're going to actually make our do something else stuff actually do something cool and interesting. So we could leave Unreal Editor open and modify our C++ code, and then use this hot compile button to compile the C++ code, but while this is kind of a nice feature, I find it to be kind of buggy. So I like to just shut down the editor completely. Go back to our source code. And we're going to say, let's see, our function will be move up and down, and our input parameter will be a theta value, which is going to be a float value. And we're just going to update this function signature. Now let's just implement this right here and now. So to move the object up and down, I guess the first thing that we want to do is we want to keep track of the theta value, and we also want to keep track of an amplitude value, and we want to do this on every single tick. So that gives us a couple suggestions. First, we actually need to implement a tick value inside of our C++ code, so we need to override the existing tick. So to do that, we just call a virtual void tick and then that has a parameter of delta seconds, and we also want to use the override keyword. And then we're going to have private values, float, theta. Amplitude is actually going to be a protected value because we want our designers to modify that. And we'll default that to 1. We only want people to be able to read that in blueprints but not modify it. But if you wanted to edit this, we're going to have edit defaults only. Now you'll notice that these different keywords are something that seems to be words that I memorized or am pulling out of thin air. These are actually all listed on the Unreal Engine documentation, so you can look up each of these and figure out what they actually mean, and you can add a whole bunch of other uProperty decorator values. I'm going to modify this so that it's distinct from the this value right here. Actually, no. If I just do move up and down, I don't actually have to pass in a theta value. That makes this a teeny bit more elegant. So let's figure out the current z value. And then we're going to multiply that sine value by the amplitude. And this is super simple math. Then we also want to get the actor's current position. That's going to be a vector. So we just want f vector cur pos for current position equals get actor location. And then we're just going to take the current position dot z, and we're going to add the z value that we pulled up here. And I could just copy and paste this here, but for the sake of debugging, it's easier to have this separately for now. And then we're going to do set actor location. Why is that not showing up? Interesting. Maybe it's position. Is it get actor position? That's not showing up either. Oh, we'll find out when we compile. The other thing that we need to do is implement the tick function. So I like to put that right after my constructor so that I can find it easily. And the very first thing that you want to do when you're overriding a tick or any inherited function is you want to call the parent class's implementation of it first. To do that, you just do super tick and then you pass in delta seconds. Oops. And then after that, we're just going to call move up and down. This is exactly the same as pulling off an execution node from the blueprint event and calling this move up and down function. And then the other thing that we want to do is modify the value of delta. So we're going to do that inside of our tick function. Or I messed up. It's not delta, it's theta. And we're adding delta seconds to it. Okay. So this sine function is going to be expecting theta to be in radians instead of degrees. So we should expect to see our object moving up and down pretty quickly. I think it should have one cycle once every 6.28 seconds. But if we wanted to, we could also multiply this by some sort of a frequency value. Why don't we actually do that right now? Let's add in a frequency as well. And we're just going to default that to 1 as well. And then to make sure that the frequency works, we're going to just multiply theta by the frequency. Ooh. Like so. And then I think that's mostly all we need. We'll find out if we have any compilation errors. Now by default every float is going to be initialized to 0, so this is a little bit redundant. Oh, I'm going to have a problem. I need to make sure that my actor knows that it can tick. I think it's going to be something like B can ever tick. I'm going to cause my, or cancel my compile. I think it's B can ever tick. It's not showing up. Primary actor? I have no idea if that is the correct syntax. Let's see. So there's a couple different ways I can figure out if this is correct. One, I can go into my pickup.h and then find actor, hit F12, pull up actor.h, and then search for primary actor to see if that's actually oh look, it's right here, I believe. Primary actor tick. I wonder if that works. I'm not sure. We'll see. If this doesn't work, I can just pull up an existing project and see what the correct syntax is. I think I might as well while I'm waiting. Let's see. I think this one does. So this project that I'm opening up is my actual Spellbound game. It's a virtual reality game that's released on Steam. So you can actually see what a production type of game looks like in Visual Studio. And by no means is this like a shining example of what it should look like. It's just something that currently works. And I guess that's kind of like the nature of game development, right? As long as it works, don't fix it if it's not broke. Okay. There's a very small chance that I need to include actor in my pickup.h. but we'll find out. I may need to delete that virtual keyword as well, I'm not sure. Alright, let's see. This may have... No, that's not a good example. Let's see. Oh, I bet base creature is a good example. Oh, it's so slow. Alright. Primary actor, B can never tick equals true. And I think I had that. Oh, we had build errors. Primary actor dot B can never tick equals true. Okay, so I did have that correct. Alright. So, we had a compile error. It says do something else is not a member of a pickup. Okay, so let's go to a pickup. That is true. Do something else is gone. So we're going to do that. It should be good enough. And that was the only error that we had. So we'll try this again. And now we wait for it to compile. I guess it's a good time to talk about the difference between implementing code in blueprints versus inside of C++ code. One of the advantages, I think, of implementing everything in C++ code, there's the obvious performance gain. I think blueprints are 10 times slower than C++, but that performance difference is most often negligible. The major advantage is that C++ does not have the same overhead costs that you would have with blueprints. So if you look at this code, you'll see that this implementation did not have us moving nodes up and down and around, and we also did not have to wire things together and manage the position. So when you have lots of blueprint nodes connected to each other, it can turn into a real mess of spaghetti really quickly and easily. With this, you don't have to worry about that at all. It's also super easy for us to copy and paste a function from one C++ class to another. In blueprints, you can't copy and paste the function. Instead, you have to recreate that function from scratch, and it's pretty tedious. So you also have a lot more flexibility to modify and copy stuff from one class to another. This would be a really good example of this would be like, let's say that we have this functionality that we put into our pickup class, but maybe we wanted to have a whole bunch of other objects have this move up and down functionality. We could copy and paste this move up and down code into a blueprint library or into a library C++ class and just call it from there. Alright, we're almost done loading here. Okay. So note that we did not modify a pickup here, at least in blueprint. We just modified the C++ code. Now if you select this, you can see that we can modify the frequency but not the amplitude. But if you go into edit pickup, we have a compile error because we deleted the function that we were calling, and we also don't want that anymore. But here we can modify the amplitude, because if you look back at our pickup.h, we have Oh, the edit defaults only should show up then. Oops. Alright. Interesting. I thought our amplitude would show up, but it is not showing up. Anyway, just to show the functionality of the code. Oh, I see, we have a small error. So you'll notice that the amplitude of this guy seems to be moving up and down quite a bit, and it's a lot more than we wanted. The reason is because our getActor position is moving this guy based off of its current position rather than an initial position. So we can fix that really quick. We're just going to close this guy down, go back to our pickup.h. I'm just going to copy this over. And then one of the values that we want to store is the starting location of our pickup. And that's going to be a vector. And then we want to store that when the actor begins playing. So we want to override the begin play. And this is just like calling the begin play event through blueprints, but instead we're calling it through C++. And we're just going to copy this function so that we don't mess it up. And I'm going to place that right between the constructor and begin play. Now some of you guys might be wondering why I want to put this in begin play instead of inside of the constructor. The reason is because the constructor gets called anytime that the object is modified, versus begin play would be storing this value only when we begin playing the actual game. So this constructor would be called even if we move the actor around in the editor. It's kind of like the construction script in a way. But the constructor is called even before the construction script is called. So this is like really good for setting default values rather than initializing stuff. Okay, now we have the start location. So instead of the current position being the current actor location, we're going to take the start location and we're going to be adding a z value to it. And we're ready to go again. Let's see, I did not mess anything up. Alright, we're good to go. Oh, I think I may have missed. Yeah, I did mess something up. I forgot to call the super for begin play. Okay, now we should be good. And now we wait. We should be wrapping up here pretty quick. I think the last thing that we'll cover after this works is debugging. So basically it's pretty straightforward. In Visual Studio you just left click here and put like this little red dot, and that's like a breakpoint. If anything in Unreal Engine while the game is running encounters a line that has this red dot, it will pause everything and Visual Studio will pop up and say, hey, you're at this spot. Would you like to step through the code? So I'm just going to demonstrate this breakpoint stuff, and we'll see the value of these variables as they change over time. But we can go more in depth on debugging in a different video. Come on. It says total build time 0.24 seconds, but I don't think that was 0.24 seconds. Alright, here we go. Alright, we have a breakpoint set, so as soon as I trigger this game, we're going to hit that breakpoint. So I'm going to hit play, our breakpoint gets triggered, and we have to wait a second for Visual Studio to catch up. So this yellow arrow is the current line that we're on. So let's see, the stuff that we're interested in, Visual Studio is being really slow here. Come on. The very first time that you hit a breakpoint, Visual Studio has to load up all those debug symbols that are in that vc.db. Let me show that to you in case you forgot. All those debug symbols are going to be stored in here as well. So this line, or this arrow, shows the line of code that we're about to execute. We have not executed it yet. We only execute it after we step past this line. The debugger has these different commands that we can use, and the ones that we're going to be most interested in is step into and step over. So if you mouse over these different variables, you can see the values of them. So theta is equal to 0.008, frequency is always going to be 1, amplitude is going to be 1, and if I step over this line of code, it's going to evaluate this mathematical expression, and now the value of z is going to be changed. Come on. So if I hover my mouse over that, you'll see the value of z, and that's been modified. You'll also see that the value of z is stored right here, and it will be in red, which means that this value has changed from the last time that it looked at this here. So the current position is going to have a whole bunch of garbage. The start location is going to have the start location. So as soon as we evaluate this line, the current position is going to be the start location. And now we're going to modify the z value of 120 by adding our evaluated z value. And now if you look at the current position, it's going to have the 120.008 added to it. And then we're just going to set the actor location. Now I can also hit continue, and if I do that, then we're going to go and hit this function again, and this is now in the next frame, right? So that means that we went through this tick function once, and now we hit move up and down, and we hit this breakpoint again, and the value of theta has now changed. So if I step over this line of code again and reevaluate this mathematical expression, remember z used to be 0.008. Now if you hover your mouse over it, it's going to be 0.39. And if we want, we can stop this breakpoint, and if we hit continue, then we're going to be returning to our game. Now you may barely be able to see it, but our ball is moving very, very slightly, and the reason is because the amplitude is 1, which is 1 centimeter, right? So it's moving 1 centimeter every 6.28 seconds. So if we wanted to modify the amount that it moves up and down, we can select this pickup and we can change the amplitude. So instead of moving 1 centimeter, let's make it move 100. Okay, so now it moves up and down by 100 centimeters plus or minus from its starting position. The total up and down movement is actually going to be 200, right? Now if you wanted it to go faster, we can increase the frequency. Let's say this is going to be 5. And now it goes up and down much faster, but the amplitude does not change. Okay? And we can go through and change these values until we find something that we really like. So maybe it's moving up and down too much and moving too fast. So maybe we'll try something like 1.25 and 10. And that's not moving, well, that might be a little closer. But now if we move into it, then we pick up the pickup and the score is now 100, and we have successfully picked up our pickup, and our player has done cool stuff with it. Okay. So that's pretty much it for like the most bare bones simple C++ and blueprint example. If you wanted to, you could also modify those variable values through the actual blueprint code itself. So maybe we wanted to have, let's just do that really quick here. We're going to have a score multiplier. And what this is doing is it's extending the functionality of our C++ class. And we want our score multiplier to by default be 1, because 1 times anything is itself, right? But I may have set that score. Oh good, it is not private. It is a protected value. So we're going to take the existing value of score, and then we're going to multiply that, and then we're going to set the score. Now we're going to have a couple different problems here. We're taking an integer, multiplying that by a float value, and then setting the float back to an integer. So maybe what we should do is change this back into an integer. And it does not show up until we actually make this visible. Compile, save. Now our score multiplier is 1. And let's make this 3. And save. Now we play. Now the base score of this was 100, but for this particular one we're going to multiply 100 by 3, and our score should increase by 300. And there we go. So that's how you have blueprints interacting with C++ code. And that's pretty much it. I think that will wrap it up for here. Cool, thanks for watching. If you have any questions, feel free to add comments to the YouTube video, and I'll try to answer them, or maybe somebody else will. There will probably be other videos but I don't know how frequently I'll be adding them. See you later. Good night.